A plane can weigh hundreds of tons. It is made of metal. It is filled with fuel, passengers, and cargo, and yet it lifts off the ground and stays in the sky for hours. Why doesn't it fall? How can something so heavy fly? Most people think they know the answer, but the truth is more interesting and more surprising than most explanations suggest. In this video, we're going to explain how airplanes actually fly. Simply, clearly, and correctly. A plane flies because it can generate a force strong enough to overcome gravity. That force is called lift. Gravity pulls everything downward, including airplanes. A large commercial jet can weigh as much as a small mountain. So for it to fly, something must push it upward with enormous force. The entire question of flight comes down to this. How does an airplane generate lift? Many explanations say that airplanes fly because air moves faster over the top of the wing than underneath it. Faster air creates lower pressure. Lower pressure pulls the wing upward. This idea is often connected to something called Bernoulli's principle. And while Bernoulli's principle is real physics, this explanation is incomplete. Air does not magically know it has to arrive at the back of the wing at the same time. So what is really happening? To understand lift, we need to change how we think about air. Air is invisible, but it is not empty. Air has mass. Air has momentum. Air resists being pushed. When something moves through air, it must push air out of the way. And when air is pushed, it pushes back. This interaction is the key to flight. An airplane wing is not flat. It is tilted slightly upward as it moves forward. This tilt is called the angle of attack. As the wing moves through the air, it forces air downward. And this is the crucial point. When the wing pushes air downward, the air pushes the wing upward. This is Newton's third law. For every action, there is an equal and opposite reaction. Lift is not suction. Lift is not magic. Lift is the result of air being deflected downward. The shape of the wing still matters. The curved top and flatter bottom help guide the airflow smoothly. This shape allows the wing to redirect air downward more efficiently. Yes, a pressure difference is created, but that pressure difference exists because the air's momentum is changed. In simple terms, the wing shape helps the airplane push more air downward. More downward air means more upward force. Engines do not lift the airplane. Engines provide thrust. They push the airplane forward. Lift comes from the wings. Even if the engines stop, as long as the airplane is moving forward, the wings still generate lift. That is why airplanes can glide. Engines exist to keep the airplane moving fast enough for the wings to do their job. Airplanes fly high not to avoid obstacles, but because the air is thinner. Thinner air creates less drag. Less drag means less fuel is needed. The wings are designed to work efficiently at high altitude. Flight is always a balance between lift, drag, thrust, and weight. Turbulence feels dangerous, but airplanes are incredibly strong. Wings are designed to bend, not break. Most turbulence is simply moving air currents. Uncomfortable, yes. Dangerous, almost never. Airplanes are built to handle forces far stronger than anything encountered in normal flight. So how do airplanes fly? Not because air is pulled upward, but because air is pushed downward. Not because of a single equation, but because physics works together. Motion, forces, momentum, balance. Flight is not a trick. It is a controlled interaction between an aircraft and the air around it. Every time a plane takes off, it is not defying nature. It is working perfectly within it. And once you understand that, the sky no longer feels mysterious. It feels engineered. This is how airplanes fly. This is how things work.